Hi guys, welcome back to our channel again. I hope you had a great day by now and feel fresh. If you remember, we've been recently talking about the periodic table in general, and we've also discussed some of the info that you can extract from it, and even some common trends. But today, we are going to elaborate on one of the most famous and clearest ways of classifying the elements using the periodic table. In this method, the elements are categorized into three major groups: metals, nonmetals, and metalloids. So, before we go to their definition and behavior, I want you to think of some examples. So, about metals, what examples can you give me? So, let me help you. In metals, we can say potassium, lead, silver, iron, gold, and many other examples. Now, let's go to nonmetals. What examples can you give me in this area? Nonmetals like chlorine, like hydrogen, like oxygen, like krypton, and more. And what about metalloids? What metalloids exactly are? So, examples like arsenic, like astatine, like germanium. Yeah, these are the examples. Okay, our periodic table mostly consists of metals. Almost 3/4 of all elements are metals, and they lie in the large lower left portion of the table. As there is no universally accepted standard definition for a metal, we cannot tell the exact number of metals in the periodic table. In some sources, it is mentioned that 92 elements out of 118 are metals or likely to be a metal. You can also see them in this table as they are separated with a blue color. Okay, but the question is, how can we distinguish if something is a metal or not? Well, I have to say that we should seek their characteristics and behavior. Now, except for mercury, all metals tend to stay solid at room temperature and they look shiny. They're also capable of conducting heat and electricity perfectly. You can also shape metals the way you want, as they are ductile, which means they can be drawn into wires, and malleable, which means they can be hammered into thin sheets. For instance, copper wires are highly in demand these days, as you can see their picture in the slide. These properties are the result of metallic bonds between metal molecules and atoms, which we discuss in another video separately. Well, our next group is nonmetals, which lie in the small upper right area of our table, and they provide somehow opposite features of metals, as they are generally gases or dull, brittle solids at room temperature. In other words, they don't look shiny at all, and although they are hard solids, if you try to shape them, they can be easily broken into pieces. Carbon can be a really good example here. Despite metals, nonmetals are often poor conductors of heat and electricity. Also, when compared to metals, nonmetals have often lower densities. As you can see in the picture, carbon is a dark solid which is not shiny at all, and on the left hand we have chlorine, which is a gas, and they are both nonmetals. Now, it's time to take a look at our last category called metalloids or semimetals. Their properties are somehow a mixture of metals and nonmetals, and again, there is a lack of clear and specific definition for them. So, memorizing their names might not be a bad idea. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine are usually defined as metalloids. They can be found along the staircase line in the table too. Well, metalloids have a metallic appearance, however, they are too brittle to have any structural uses and are fair conductors of electricity. Chemically, they behave mostly as nonmetals, but in general, we can state that their physical and chemical properties are at an intermediate level in nature. Now, to make sure that you are completely familiar with these three groups and their elements, let's head to some exercises. In each step, we have one element for you. You have 15 seconds to think, and you should find a reason to identify if the element is a metal, nonmetal, or metalloid. Then we check it together. Now, with the first one, magnesium. Take your time. Okay, magnesium is in group 2A, which is in the left area of the table. And we all know that magnesium is a solid at room temperature. And as you can see, it is really shiny. So it should be a metal. Okay, hope you answered it correct. Let's go to the next one. Nitrogen. With this one, we can simply say that nitrogen in the form of N2 is a gas at 25 degrees Celsius, so it must be a nonmetal. Okay, let's go to the third one. Gold. Okay, as you obviously know, and it is shown in a picture, gold is a solid and it looks shiny. It is also an extremely perfect conductor of electricity. So, this one is a metal too. Okay, let's head to the last one and wrap it up. Silicon. Well, silicon is famous for its usage in electronic chips and boards, and it's famous because of its semiconducting behavior. Also, by taking a glance at the table, we can find out that silicon is a metalloid too. That's it for today. Thank you so much for watching our video. Hope you enjoyed it and found it useful. I would really appreciate if you subscribe to our channel for more chemistry content in the future. See you in the next video.